What's going on, guys? Medicine in 3 minutes, back with another video. As usual, we're going to get straight to the point. We're going to keep the subject brief and clear, and as usual, illustrated. So let's get straight into it. So today we're going to be talking about the menstrual physiology. Now, menarche, essentially, it describes the first menstrual period a person has. So typical mean age is going to be anywhere between 12 and 13 years on average. When the first menstrual flow begins, this is technically the start for the potential of reproduction. This doesn't, in most cases, and as you're going to see later on, the menstrual period is an ovulatory, meaning there is no capability to reproduce, but it starts the process. And so reproduction most likely will not occur until regular ovulations start, which is usually within 2 to 3 years after the first menstrual period. So let's talk about the reproductive years. So like we mentioned earlier, menarche is going to describe the transition towards the reproductive potential, but it does not indicate the start of reproductive potential. Typically, the reproductive potential is going to start at the age of 15, give or take, and end at the age of 45, give or take, again, all depending on the individual. And how we come to that range is through the number of cycles where we have menstrual flow. So typically there's one every single month. And so if we have on average 360 cycles, divide that by 12, you're going to get roughly 30 years where there is a potential for reproduction. Now, what do we mean when we say reproductive potential? We're essentially just saying the ability for the female body to take diploid cells and through the process of meiosis, convert them into haploid cells, which is essentially just the splitting of the chromosomes. Now, the potential for fertilization, which is what is going to allow us to reproduce, cannot happen in a healthy manner unless we have haploid cells. And again, this is the reproductive potential. It is the potential to go from diploid to haploid. Cool. So now let's talk about these cycles, these 360 cycles we just mentioned. So the way the cycle is going to go, you have between 1 and 20, it's roughly 28 days. Between 1 and 7 days, this is going to be the menstruation period. Between 7 and 14 days, we have the pre-ovulation, which is the follicular phase. Everything leads up to the ovulation phase, which is 1 day, roughly in the middle of the cycle. And then post-ovulation, pretty straightforward, is the luteal phase, which is going to be from 14 all the way until the end, and then the cycle starts again. Now, I will mention that during the pre-ovulation, the follicular phase, we have proliferation, and then during post-ovulation, we have secretion, and we're going to go into that a bit later in the video. Okay, so we spoke about the follicular phase and then the luteal phase. So as we can see in this diagram here, on the left we have the basalist zone and then we have the functional zone. So there's going to be a transition between the basalist zone and the functional zone, and regeneration is always going to take place in this zone, and there's always going to be a transition from here to here. Now, when looking at the functional zone, when progesterone levels fall, there are going to be arterial spasms. There's going to be ischemia, and then the release of prostaglandins, which is going to cause necrosis. And so the functional zone will disappear, and we restart the cycle with menstruation. Now, let's jump ahead to the end of the reproductive potential. So we're going to speak a little bit about menopause. So really, what is menopause? It is the point in time, and you can pull statistics, typically anywhere between 45 and 50 is the average age in which we're going to have the last menstrual flow. Technically, that means that there are follicles in the histology of the ovary, but they're not functional. And this signifies the end of reproductive potential. This turning point is menopause. Okay, now we went past the reproductive potential. Let's go back to the cycle. We have, like we mentioned, a cycle of 28 days. Again, we're going to assume typically right at that middle point. So we'll say 14 days in theory is when ovulation is going to occur. And the menstrual cycle, remember this diagram here. So we spoke about the follicular phase and the luteal phase. Okay, so the follicular phase is going to be split up between the menstrual phase and the proliferative phase. So the menstrual cycle is going to begin with the first day of the menstrual period. The length of the menstrual phase is going to be anywhere between 3 to 7 days. Again, like I mentioned here, it's variable, which means 3 to 7, we don't know. It depends. The proliferative phase is when estrogens are predominant and stimulate proliferation of the endometrium, and that is why it's called the proliferative phase. Okay, now let's talk hormones. So, like as we can see here, we have the cycle. Right here's the middle point. Let me pull out the laser. Right here, we have the middle point, which is 14 days. Okay. To the right is going to be the luteal phase. We split up the follicular phase into two parts. Okay. So you'll notice in the first half of the follicular phase, we have a rise in FSH. This is going to stimulate the follicle, which is going to produce estradiol. Now, you'll notice in this diagram, throughout the follicular phase, the LH is going to remain stable for the first half of the cycle. You'll notice that FSH falls. Yet, even when it falls, estrogen keeps climbing. Estrogen levels keep climbing. Now, you might ask yourself, how is this the case? It seems that there's a correlation over here, and yet it's going to keep going up. The reason is because there is a dominant follicle which has more FSH receptors, which is going to keep on producing estrogen despite the fall of FSH. Now, shameless plug here. We have some really, really useful resources, both on Amazon and on our website, cdbooks.ca. Feel free to check the links in the description. If you like these kinds of videos and you feel like you might benefit from some material, follow the link. Now let's talk a little bit more about the process in the first half of the cycle. So speaking about hormones, we have the hypothalamus. At the beginning of the cycle, it's going to secrete GnRH. GnRH is going to travel through the portal system and circulate to the anterior pituitary gland. Once here, as a response to the GnRH, the anterior pituitary gland is going to release FSH, which is going to make its way through peripheral circulation down to the ovarian follicle. Now, what does the ovarian follicle do? In response to this FSH, it's going to produce two hormones. The first is estrogen, the second is inhibin. Now, both of them are going to send a feedback to the anterior pituitary gland, which is going to let them know, hey, I've had enough. I've produced enough estrogen and inhibin. You can stop sending me FSH, and that's what's going to stop the secretion of FSH. Now, here's the key thing. So when you're in menopause, what ends up happening is that because the ovarian follicles, there's an absence of function, they're not going to be able to produce inhibin and estrogen. And so there's nothing to send this signal back to the pituitary gland. And so there's an increase in the FSH. There's nothing telling it to stop, so it keeps on building. Now, you're probably asking yourself why we had this diagram in the last slide and we really talk about it. So in the last slide, obviously, we're talking about the follicular phase. Now, let's talk a little bit more about the luteal phase, and that's kind of where this diagram comes in handy. So corpus luteum is going to produce progesterone. It's going to peak right around the middle of the luteal phase. And at this point, the corpus luteum is going to look around. It's going to, ask itself, are we pregnant? Do I need to keep producing progesterone? Progesterone is built up in preparation for pregnancy, and corpus luteum is going to ask, is there any beta-hCG? If there is none, then that signifies to it that there is no pregnancy. So what's going to end up happening is there's going to be that crash in progesterone levels, like we mentioned earlier in the video. And what this is going to do is it's going to cause those arterial spasms, the necrosis, like we mentioned earlier, the release of prostaglandins, and again, starts the cycle up again because we get endometrial menstrual bleeding. Now, going back to the corpus luteum, if fertilization does not occur, it's going to disintegrate and it's going to turn into corpus albicans. Corpus albicans undergoes luteolysis with scar tissue, and we'll explain that a little bit more in depth in the next slide. So that brings us back to what is the difference between corpus luteum and corpus albicans. One is before we find out if there's pregnancy, in preparation for pregnancy through the production of estrogens and progesterone, which are going to support pregnancy. And once corpus luteum realizes that there is no pregnancy, it's going to become corpus albicans. It's going to disintegrate, and corpus albicans is going to undergo luteolysis with scar tissue. Simple as that. So yeah, that wraps up this video. Thank you guys so much if you made it all the way here. We appreciate every single ounce of support. Please drop a like, leave us a comment if you have questions, something you liked, something you didn't like. We're always open to feedback. And feel free to visit the websites or check us out on Amazon. And in case you didn't, just smash that subscribe button, and we'll see you guys in the next video.